Strap in, everyone, because today we're diving headfirst into the quantum realm. We're talking about quantum entanglement.
Ooh, yeah.
And let me tell you, it's a topic that's guaranteed to make your head spin.
Absolutely. It's one of those concepts in physics that just seems to defy common sense.
Totally. We're talking about particles linked across the universe, acting like they're connected by some invisible thread.
Right. It's like they're having a secret conversation faster than the speed of light. It's no wonder even Einstein called it spooky action at a distance.
Spooky action at a distance. I love that. Okay, so for our listeners who maybe haven't encountered entanglement before, let's start with the basics.
Sounds good.
What exactly are we talking about when we say quantum entanglement?
Well, imagine you have two particles that are born together, like from the same quantum event. They're linked in a way that even if you separate them,
Like really, really far apart?
yeah, across the universe even, they still act like they're connected. It's as if they share the same fate no matter how far apart they are.
Okay, so I'm picturing like two tiny marbles linked by an invisible string. But what does that connection actually mean? What are they doing that's so weird?
So here's the truly bizarre part. If you measure the state of one of those particles, like say its spin,
Spin, like if it's spinning up or down.
exactly, you instantly know the state of the other particle, even if they're light years apart. It's like they're in sync no matter the distance.
That's crazy. It's like they're communicating faster than light, which we know is supposed to be impossible.
Right, it's one of those things that makes you question everything you thought you knew about the universe. It really highlights the strangeness of the quantum world.
And I remember reading in one of the sources they even used the visual of two particles connected by this like glowing thread, which I thought was a cool way to imagine it.
Yeah, I like that visual too. Helps make it a bit more concrete, even though it's such an abstract concept.
So how is this even possible? I mean, it sounds like magic or something.
Well, to understand entanglement, we need to talk about another weird quantum concept: superposition.
Okay, bring on the weirdness. I'm ready.
So you know how a coin spinning in the air is both heads and tails at the same time until it lands?
Yeah, it's all about the suspense.
Well, in the quantum world, particles are kind of like that spinning coin. They exist in a fuzzy state of possibility until we actually measure them.
So they're not just spinning up or down, they're kind of doing both at the same time.
Exactly. It's only when we observe them that they choose a specific state. And this is where entanglement gets really wild. Because
Yeah.
the moment one entangled particle chooses a state, its partner instantly does the opposite, even if they're across the universe from each other.
Okay, so they're not actually sending signals back and forth.
Nope. No information is traveling faster than light.
So what is it then? Are they like psychically linked or something?
You could think of it that way. It's more like they're two parts of a single unified system, even when separated by vast distances. Their fates are intertwined.
Wow. Okay, my mind is officially bending.
I get it. It's a tough one to wrap your head around. Even Einstein had trouble with this.
Oh yeah, wasn't he pretty skeptical of entanglement?
Oh, absolutely. He famously called it spooky action at a distance. He and his buddies even came up with this thought experiment called the EPR paradox, where they basically argued that quantum mechanics had to be incomplete because entanglement seemed to violate his theory of relativity.
Because nothing can travel faster than light.
Right,
Yeah.
exactly. So they came up with this idea of hidden variables, these unseen factors that we can't measure that would explain how the particles know what state to be in even when separated.
Like some secret instructions they got before they were separated?
Exactly, like a cheat sheet tucked away somewhere. But then in the 1960s, physicist John Bell came along and he was like, hold on, we can actually test this. And he devised a way to see if these hidden variables really existed.
Did they?
The results were pretty shocking, even to the physics community. Experiments, like the one Elaine Aspect did in 1982, have consistently shown that those spooky connections are the real deal. No hidden variables needed.
So Einstein was wrong.
On this one, yep. It seems reality is far weirder than even he imagined.
Talk about a reality check. Okay, so we've established that entanglement is real, it's spooky, and it's even weirder than Einstein thought.
Pretty much.
But I'm still wondering, what's the point? Is this just some bizarre quirk of the universe? Or can we actually do anything with entanglement?
Well, buckle up, because that's where things get really interesting. It turns out, entanglement is not just a theoretical curiosity. It's the key to some truly groundbreaking technologies. Like, have you heard of quantum computers?
Oh yeah, they're all over the news these days. Supposed to be able to solve problems that would take regular computers like millions of years.
Exactly. And guess what? Entanglement is what makes those quantum computers so powerful.
Okay, so we're shifting gears now. We've been deep in the weeds of the weirdness, but now you're telling me this has real-world applications.
Oh, absolutely. And to understand how it all works, I think it's helpful to use a classic analogy. Have you ever heard of the gloves in boxes thought experiment?
I think I have, but remind me, it's been a while.
Okay, so picture this. You have two gloves, one left and one right.
Okay, I'm with you.
You put each glove in a separate box, and you send those boxes to two different places, maybe even different planets.
Gotcha. So until I open a box, I have no idea which glove is inside.
Exactly. Just like those particles in their fuzzy, undefined state.
Okay, so how do these gloves relate to entanglement?
Well, imagine you open one of the boxes and see a left-hand glove. In that instant, you know the other box contains the right-hand glove, no matter how far away it is.
I see. It's like they're linked, even though there's no way for them to communicate.
Exactly. And that's kind of like entanglement. Knowing the state of one particle instantly reveals the state of the other, even across vast distances.
Okay, that's a really helpful way to think about it. But this whole concept still makes me wonder, if those particles are linked across the universe, does that mean we can finally break the cosmic speed limit and send messages faster than light?
I know, wouldn't that be amazing? But unfortunately, the answer is no.
Really? Why not? It seems like it should be possible.
Well, the connection between entangled particles is instantaneous, but you can't actually use it to transmit information faster than light.
Oh, man. So no instant messages to aliens across the galaxy.
Yeah.
Bummer. But, so what good is entanglement then if we can't even use it to send messages?
Oh, trust me, it's good for a lot more than just sending messages. Like I was saying, it's the secret ingredient that could revolutionize computing, make communication ultra-secure, and even help us understand the very fabric of reality.
Okay, now I'm intrigued. But I think we'll have to save that for part 2 of our deep dive.
Deal.
You've officially piqued my curiosity, and I can't wait to explore those applications further.
It's going to be a wild ride.
All right, so last time, we left off with the tantalizing promise of entanglement's real-world applications.
Right, yeah.
And I have to admit, I'm still a little bit mind-blown by the fact that this isn't just some theoretical idea.
Oh, yeah, it's definitely moved out of the realm of pure theory and into the practical.
So where do we even begin? What kind of things are we talking about when we say entanglement has real-world applications?
Well, for starters, it might be happening all around us in nature more than we realize.
Really? Like where?
Well, there's some really interesting research being done on photosynthesis.
Photosynthesis, like how plants use sunlight to make energy.
That's the one. It seems like entanglement might play a role in how efficiently plants can transfer energy within their cells.
Wow, so plants might be using quantum entanglement to, like, power themselves.
It's a possibility. It just goes to show that these quantum phenomena aren't confined to labs and equations. They might be woven into the fabric of life itself.
That's pretty amazing. It's like nature got there first, figuring out how to use this weird quantum stuff long before we did.
I know, right? It's humbling.
But okay, let's get back to the practical stuff. You mentioned quantum computers before the break, and you said entanglement is what makes them so powerful. Can you unpack that a bit more?
Definitely. So you know how regular computers use bits, those A's and ones, to store and process information?
Yeah, that's like the basic language of computers, right?
Yeah. Right. Well, quantum computers use qubits, which are kind of like bits on steroids.
Okay, how so?
Well, thanks to that whole superposition thing we talked about earlier, qubits can be both 0 and 1 at the same time.
So it's like they're running on all possible answers at once.
Kind of. Now, when you entangle those qubits, you create these powerful connections that let them work together in ways that classical bits just can't.
So by entangling qubits, we can unlock a whole new level of computational power.
Exactly. That's why quantum computers can potentially solve problems that would take classical computers billions of years.
That's mind-blowing. Like, what kind of problems are we talking about?
Oh, all sorts. Think about designing life-saving drugs, creating entirely new materials with properties we can only dream of, or cracking the codes that protect our online data.
Okay, now you're really getting my attention.
Yeah.
So you're saying we could use quantum computers to, like, cure diseases or design super strong, lightweight materials for spaceships?
Potentially, yes.
Wow, it's like something straight out of Star Trek. So entanglement is basically the key to unlocking all of that.
It's one of the key ingredients for sure. It's like the universe handed us this incredible tool and said, go figure out what you can do with it.
That's a pretty cool way to think about it.
Uh-huh.
But it doesn't stop there, right? You mentioned something about ultra-secure communication, too.
Oh, yeah, that's another huge area where entanglement could have a massive impact. Imagine a network where hacking is basically impossible because any attempt to eavesdrop would actually change the information being transmitted.
Whoa, hold on. You're saying we could create a completely unhackable internet?
It's a possibility. That's the idea behind quantum cryptography. Remember that Chinese satellite Machiris?
Yeah, the one that entangled particles
I
over the
know.
really long distance.
That's right. That was a huge proof of concept for building a global quantum internet.
A quantum internet? That's insane. It's like something out of a sci-fi movie.
It sounds like it, but it's closer than you might think, and the implications are huge.
So let me get this straight. A quantum internet would be super fast, super secure, and could connect people and information in ways we can't even imagine right now.
That's the general idea.
That's incredible. But I also have to wonder about the potential downsides. Like, could this kind of technology create even bigger divides between those who have access to it and those who don't?
Yeah, that's a valid concern. And there are other ethical questions too, like who controls this technology? How do we ensure it's used for good and not for harmful purposes?
It's like every time we make a technological leap forward, we also have to take a step back and think about the consequences, both good and bad.
Absolutely. It's not just about the science, it's about the societal impact.
Okay, so we've got these amazing potential applications, but there's also this whole ethical dimension we need to consider. But before we go there, there's still one thing about the science that's bugging me. We keep talking about the connection between entangled particles being instantaneous, but doesn't that mean they're communicating faster than light?
Yeah, no, it's tempting to think that.
Because that would break Einstein's theory of relativity, right? And we know that theory has been pretty well tested.
Yeah, it has. And don't worry, entanglement doesn't actually break relativity. While the connection is instantaneous, you can't actually use it to send information faster than light.
So it's like a loophole in the laws of physics.
You could think of it that way. It's a reminder that the universe is full of surprises, and it doesn't always follow the rules we think it should.
That's both comforting and a little bit unsettling at the same time.
I know, right? But it's also what makes this whole topic so fascinating.
So if entanglement doesn't actually allow for faster than light communication, what does it tell us about the nature of reality? Like, if these particles can be connected across vast distances, does that mean our everyday notion of separation is just an illusion?
That's where things get really philosophical, and there are a lot of different interpretations of what entanglement might mean.
Okay, I'm ready to get philosophical. Hit me with those interpretations.
Well, we talked about the many worlds interpretation, which suggests that every time a quantum measurement is made, the universe splits into multiple branches, each representing a different outcome.
Yeah, the whole parallel universes idea.
Right. Now, some physicists believe that entangled particles aren't actually communicating across vast distances, but rather they're existing in multiple states simultaneously, each state corresponding to a different branch of the multiverse.
So it's like when we observe an entangled particle, we're essentially choosing which branch of the multiverse we experience. And the other particle, no matter how far away, is instantly affected because it's also in that same branch.
That's the gist of it. Of course, not everyone agrees with that interpretation.
Yeah, it does sound pretty wild.
There are other interpretations that don't involve parallel universes. Some physicists believe that entanglement points to a deeper level of reality, a hidden realm where our classical notions of space and time break down.
So like, there's a whole other layer to reality that we're just not equipped to perceive.
That's one way to think about it. It's like there's this whole other level of interconnectedness that we're just starting to glimpse.
Okay, that's officially blowing my mind.
It's mind-blowing stuff, that's for sure.
Yeah.
But it's also incredibly exciting because it means we still have so much to learn about the universe and how it works.
Well, I think we've officially reached the limit of my brain capacity for one episode.
Yeah, we've covered a lot of ground today.
But you know what? I feel like we've only just scratched the surface of this entanglement thing.
Oh, we definitely have. There's so much more to explore.
So if you're as intrigued by all of this as I am, join us for the final part of our deep dive, where we'll try to untangle even more of these mysteries. And maybe, just maybe, we'll find some answers along the way.
Sounds like a plan.
Okay, so we've made it to the final part of our quantum entanglement deep dive. And honestly, I'm still reeling from everything we've talked about so far. It's like the more we learn about entanglement, the weirder and more amazing it gets.
Right. It's definitely one of those topics that just keeps getting more fascinating the deeper you go.
Absolutely. So I'm curious, where do we go from here? What are the big questions that researchers are still trying to figure out when it comes to entanglement? What's next for this field?
Well, one of the big ones, and we've touched on this before, is the whole quantum internet thing.
Oh yeah, that was mind-blowing.
It really is. Building a network where information is transmitted not through, like, electrical signals, but through entangled particles.
Right, and that would make it super secure, right?
Yeah.
Because any attempt to hack it would just mess with the entanglement.
Exactly. It would be like the ultimate cybersecurity system. It's still early days, but a lot of people think that a quantum internet is a real possibility, not just science fiction.
So how would we even go about building something like that? Like, where are we at with the technology?
Well, remember that Chinese satellite we talked about, Metis?
Yeah, the one that entangled particles over a crazy long distance?
That was a huge step forward because it showed that we can actually create and maintain entanglement over long distances, which is essential for building a global quantum network.
So we're not just talking theory here, there's actual progress being made.
Oh yeah, there are labs all over the world working on this stuff, trying to figure out how to make entanglement more robust and reliable. And honestly, the implications are huge.
Yeah, I mean, a quantum internet could revolutionize so many things, right? Like you said, it could be used for secure communication, but it could also be used for things like super fast computing and even teleportation.
Teleportation. You're really thinking big now.
Well, hey, if we're talking about quantum entanglement, why not go all out?
Yeah.
But okay, maybe teleportation is a bit far-fetched for now. But seriously, the potential applications are pretty mind-boggling.
They really are. Imagine like scientists all over the world being able to collaborate on experiments in real time, sharing data with perfect security and speed, or doctors being able to diagnose and treat patients remotely with incredible precision, or even just being able to video chat with someone on the other side of the world with zero lag and perfect privacy.
It's like the possibilities are endless.
Yeah, pretty much. But of course, with any new technology, there are always ethical considerations.
Right, like we have to make sure that this kind of power isn't misused or doesn't end up widening the gap between those who have access to it and those who don't.
Exactly. We need to start having these conversations now so we can make sure that a quantum internet, if and when it arrives, benefits everyone and is used for good.
Totally. Okay, so we've got the quantum internet on the horizon, but what about the science itself? What are some of the other big mysteries that researchers are trying to unravel when it comes to entanglement?
Well, one of the things that's still a bit of a puzzle is how to create entangled states that are more, how do I put this, more robust.
Robust, like less fragile.
Exactly. Right now, entanglement is very sensitive to noise and interference. Like, even tiny changes in temperature or magnetic fields can mess it up. So researchers are working on ways to create entangled states that are less susceptible to that kind of interference.
So they're trying to make it more practical for real-world applications.
Right. And another thing they're working on is scaling up entanglement. Like, right now, we can mostly entangle just a few particles at a time, but imagine being able to entangle, like, millions or even billions of particles.
Whoa, what could we do with that?
Oh, who knows? It's like opening up a whole new realm of possibilities. Maybe we could create entirely new forms of computing or develop ultra-sensitive sensors that can detect things we can't even imagine right now.
It's like we're just at the beginning of understanding what entanglement is and what it can do. It's both exciting and a little bit daunting, you know?
Totally. And that's what makes this whole field so captivating. It's like we're constantly pushing the boundaries of what we thought was possible, and who knows what amazing discoveries are waiting just around the corner.
Well, I have to say, I've really enjoyed this deep dive into the world of quantum entanglement.
Me too. It's always fun to talk about this stuff.
I mean, it's definitely been mind-bending at times.
Oh yeah, it's a brain workout for sure.
But it's also been incredibly inspiring. It's like learning about entanglement gives you this whole new perspective on the universe and our place in it.
It really does. It makes you realize that there's so much more to reality than what we can see and touch. And it makes you wonder what other mysteries are still out there just waiting to be discovered.
Absolutely. So for our listeners out there who are now as fascinated by entanglement as we are, what would you recommend they do to learn more?
Well, there are some great books and articles out there, and a lot of universities offer online courses on quantum mechanics. And of course, there's always the internet.
Just be careful what you click on, because there's a lot of misinformation out there too.
Good point. But yeah, there's a ton of great resources available. So just, follow your curiosity and see where it leads you.
I love that. Well, on that note, I think it's time for us to wrap up our deep dive into the world of quantum entanglement. It's been a wild ride, but I wouldn't trade it for the world.
Thanks for having me.
Thanks for being here. And thanks to all of you for listening. And remember, the universe is full of surprises, so keep exploring and never stop asking questions.